Infinite discontinuity there. So if you don't have, the use of your calculator, there's a way to look at it. Okay, you plug it in, that's what happens. Well, at x equals 1, you plug in 1 into this thing, and you get 1 minus 1 over 1 squared 1 minus 4 plus 3. In this case, it equals what? 0 over 0. Now this is a little different, and this is where strange things have been happening. Every time this 0 over 0, something like this has been happening. This is called the indeterminate form. Anytime you plug in and you get 0 over 0, you can't determine what type of discontinuity or any of the information. You have to do a little more work. Okay, that's what we're going to do in a second. So, if you want the function value at 3, you get something like this. You have an infinite discontinuity. You get this 0 over 0, you need to do a little more investigation. Okay? And if you check any other value, let's check like at x equals 0. If I plug that into this equation, I get negative 1 over 0 minus 0 plus 3. 0 minus 0 plus 3 is negative 1/3. Okay? So again, if you just plug in a value and you get a value, okay, that is f of 0 is equal to negative 1/3. Okay? Those are kind of the three things that are going to be happening. So if we do a little more investigation on this indeterminate form, we're going to see that this happens in the denominator. You get this canceling out. This, you have x minus 1 divided by x minus 1 times x minus 3. And these are always going to cancel out. So if I do the limit as x approaches 1, limit as x approaches 1 of this x minus 1 over x minus 1 over x minus 3. Okay? Well, you can go through the whole process. Now, you can't do this for function values. You can't just say, okay, these cancel out if you're talking about function values. Okay, these are going to cancel out, which equals the limit as x approaches 1 of 1 over x minus 3. So is this the... Yeah, 3 and 1, right? Okay. Yeah, 1 over x minus 3. Now we can plug in that value. Does that make sense, you guys? In the limit, though, if you want the function value, this doesn't make sense. The function value doesn't exist at 1. It's a 0 over 0 thing. But what's happening with the limit? You can plug in, and you're going to get negative 1 over 2. Is that right? Negative 1/2. So what is that telling you about this problem, about what's happening at 1? We just did all of this. So we've been doing this, all this limit stuff. What is that telling me? Yeah. That means the limit does exist. The limit from the left and the limit from the right is negative 1/2. What's the function value there? What does that mean about continuity? It's discontinuous. So if you have a limit value, but you don't have a function value, that's where you're going to have that removable. You're going to have that one little hole sitting right there. Does that make sense? And things like that are going to happen with the indeterminate form. When you plug in that x value, and you get this 0 over 0. It's not an infinite discontinuity, so you have to do a little more investigation. So when I calculated the limit, you do have a limit value. Since you have a limit value and you don't have a function value, you're going to have a removable discontinuity. Okay, how are we feeling with that? Okay, so let's look at a couple other examples. Specifically, sine of 4x over x. Graph it, there's a little picture up there. What is the limit as x approaches 0 of sine of 4x over x? what's the limit as x approaches 0 sine of 4x over x? Is that what you're seeing? Does it shoot up straight down? Zoom out a little bit on yours. Do a zoom 6 on your Windows. Anyone have an answer? It's 4. Why does this approach 4? Well, if we do the algebra on it, I'm going to take this thing and multiply the top and bottom by 4. You're going to get the limit as x approaches 0 of 4 times sine of 4x over 4x. I'm going to split these two things up, this and this, using my limit rules. The limit as x approaches 0 of 4 times the limit as x approaches 0 of sine of 4x over 4x. Limit as x approaches 0 of sine of something divided by that same something, what's that equal to? What's the limit as x approaches 0 of sine x over x? Guys? 1. What's the limit as x approaches 0 of sine of 4x over 4x? Yeah, as long as what's x? As long as this is the same as this limit is going to equal 1. What's the limit as x approaches 0 of 4? 4. This limit is equal to 4 times 1, which is 4. That's what you were seeing, right, Magali? Yeah. It goes up just like the other one did, and it approaches 4 from the left and from the right. Now, what is the function value? What is sine of 4x over x when x is equal to 0? It's 0 over 0. Yeah, it's the same indeterminate form. The function value, f of 0, is equal to 0 divided by 0. It's the indeterminate form. You can't, so what does that mean about the continuity at 0? It's a removable discontinuity. Does that make sense, you guys? Okay? See if we can squeeze in one little example. Here's an application for the intermediate value theorem. So we saw one little example. Here's something else. I want you to show me that the cosine of x is equal to x. It has a solution on the interval 0 to 1. So if you graph cosine of x on y1 and you graph x on y2, you'll get this little graph on the right, and you can see between 0 and 1 that there's a solution. You can see it. Do you see it, Katie? So a way to solve that is if you bring everything over to one side in the equation. So instead of cos x equals x, you subtract x from both sides, and you get cos x minus x equals 0. Find the two function values at the endpoints. If one is below and above 0, you can use IVT to prove it.